So you might be living here on campus, or you might be commuting here to come to class. It might be your first week here, or you might be in your final term. Have you thought about the geology that's underneath your feet every time you come here?
Hello Geos Explorers. This week's topic is the Botany Sands. This is the geology that is underneath your feet when you're on UNSW campus at Kensington. So what are the Botany Sands? They are sediments that have been deposited in the Quaternary period of geological time. And the Quaternary is the period that starts 2.6 million years ago and continues to the present day, or the Anthropocene. And the Quaternary period is the period of the Ice Ages. The Botany Sands cover approximately 46 square kilometres of the land surface in Sydney. In the figure on the right hand side, you can see the Botany Sands are delimited by the black line. Botany Bay is in the middle. To the north of Botany Bay, you can probably see the outline of Sydney Airport and the runways. And UNSW campus is on the northern side of the bay and within the extent of the Botany Sands. The Botany Sands deposit was formed in a shallow depression, a basin called the Botany Basin. So this is a lower elevation part of the land surface of the Triassic Age Hawkesbury Sandstone. So if you go underneath the Botany Sands, you will find the Hawkesbury Sandstone. It has a basin shape, and in that lower depressed area, there's space for these sands to accumulate. So the Botany Sands are Quaternary Age, and the sediments underneath them are Triassic Age, and the Triassic Age is between 200 and 250 million years ago. There was a huge gap of missing sediments between the two. The modern Botany Basin is open to the sea, and in the past, sea level changes would have led to the deposition of marine sediments in the basin when the sea level was high, estuarine sediments when the sea level was a bit lower, and terrestrial sediments, land-based sediments, when the sea level was lower still. And so the Botany Sands preserve a record of the landscape of the region when it was an inland dune and swamp system, and the sediments deposited related to the sea level at the time that the sediments were formed. So why are the Botany Sands important? Well, firstly, like all geological sediments, they are time capsules of past environments here on the planet Earth. And the Botany Sands themselves contain an environmental Earth history that starts around 140,000 years ago. So that's the oldest, the deepest Botany Sands sediments. And 140,000 years ago is the period of the penultimate glacial stage, the penultimate ice age, so the one before last. And the final period of sediment formation, which was a period when dunes had formed and stabilized, occurred in what is called the Holocene epoch of the Quaternary. So the Quaternary is divided into epochs, and the Holocene epoch goes from 11,700 years ago up until the present day, or the Anthropocene. And the Holocene is the period of climate after the last glacial period. So it's after the last ice age, and it's a period of warmer climate. And the Botany Sand sediments have been analysed using grain size analysis. And by measuring the diameter of the sand grains in the rock, it's been determined whether they've been transported by water or if they were wind blown. And the example on the right hand side shows some pictures of some dunes. This is in Centennial Parklands, close to Sydney, and you can just see the dune-like shapes of former sand dunes that are now covered by the tree and forest cover. A second reason why the Botany Sands are important is that they explain Sydney's landscape today. The city that you walk around, drive around, catch the train or bus is particularly flat, and that's because you're travelling over a basin that's infilled with Botany Sands sediments. So can you visualize that? A shallow basin that has been infilled over the last 140,000 years with sediments, most of which were originally deposited as wind-blown sand dunes, building up over time. And so this has led to a relatively flat landscape. However, there are some steeper gradients, and that's where this wind-blown material, these wind-blown sands, have been blown up against the sides of the basin to where the Jurassic rocks are exposed. That's the case on campus. When you walk up the steps from lower campus to upper campus, you're walking up one of these steeper gradients where the sands have started to accumulate and it's getting towards the edge of the basin. It's also important to note that the Botany Sands are, by its nature, very sandy and very porous. Water percolates very quickly through sands because it's got high porosity between the sand grains. So this means every time it rains, if it rains onto the Botany Sands, the water can infiltrate quickly. And the flat landscape and the high porosity of the sands means that you don't see any major rivers in the Botany Basin. And the third reason why the Botany Sands are important is that because of the high porosity, sediments can have water present in these pore spaces, which means that Botany Sands is an important groundwater aquifer. It can hold a lot of water. And in the picture you can see the UNSW roundhouse, but did you know that there was a groundwater bore right next to the roundhouse which is extracting water from the Botany Sands? And the bore is underneath the metal infrastructure there on the left-hand side, which is the pump. Groundwater will be considered in more detail in a later week. However, you will probably use groundwater from the Botany Sands whenever you come onto campus, because UNSW has a license to extract the groundwater and use it for non-potable use. That means non-drinking use. So you will find that groundwater is used for toilet flushing, and often for use in the teaching and research labs. And you'll often see signs around campus saying the water is not potable, not drinkable, and that's because it is this groundwater that is being reused and recycled. So what is happening in class this week? Well, it's a field class week, and the field class is the Earth and Environmental Science campus field trip. And the aim of this field class is to introduce you to various earth and environmental science features of UNSW Kensington campus, which is situated on the Botany Sands, and it will focus in particular on many of the features of the Botany Sands itself. Your learning outcomes include finding out about the geology and modern landscape, campus hydrology, and how the stormwater is captured. You'll have a chance to explore the displays in our home building for the school, building E26, the Biological Sciences building. You'll learn about how other campus-based fieldwork is conducted from the School of Biological, Earth and Environmental Sciences. And you will learn about some of the research facilities that are available to earth and environmental scientists across campus, and which could include your own research projects later in your university career. So what do you need to do before the field class? Well, before the class, I have 2 papers and a web resource here that I'd like you to read and understand. There'll be a pre-class test, and the learning outcomes are listed on the next slide. The first paper, by Gale et al. 2018, is actually on a specific feature in the Botany Sands, something called the Waterloo Rock, and that's not what I want you to look at in this paper. I only want you to read the Botany Basin subsection, which gives a very good overview of the Botany Sands. The paper by Gale and Wales from 2022 is a paper that analyses the particle size of the sands to work out that the Botany Sands are a quaternary dune and swamp system. And this is a technical paper, and sections 5 and 6, the methods and results, are very technical, and they use a grain size or phi scale that you may not have come across before. So what I recommend you do is use the Wikipedia resource to understand what the phi scale is before getting into sections 5 and 6 in the paper. But from that reading, I would like you to have an understanding of how the authors use grain size to actually work out the environmental history of the Botany sands. And what do you need to understand before you attend the campus field class? These are the sort of questions that you may be questioned on in the pre-class test. I'd like you to understand what is the Botany Basin. I would like you to understand when the Botany sands were deposited and what the likely climatic conditions were. I'd like you to understand what environmental processes deposited the Botany sands. I would like you to understand how geologists and geomorphologists record grain size, that's the phi scale, and how the measurement of grain size allows us to determine the divisional environment of the sediments. So I hope you enjoy the reading, and I look forward to seeing you in class.